In the previous video, we just learned to configure the ADC channel of the microcontroller STM32F4 and we just converted using a single channel PA1 by configuring that particular channel as ADC1 channel 1. So in that particular video, we just did a single shot conversion, which is meaning like one shot conversion. So here we are just starting the conversion, waiting for the flag, and again we are reading the result using a temporary variable. So this type of conversion is known as one shot conversion, where you need to start the ADC conversion and then we want to wait for the ADC to complete, and further we want to read the data. So there is another option called continuous conversion, where you need not start the conversion. Instead, the ADC module itself start the conversion and it will be providing the result as soon as the result is ready. So we are just going to learn the continuous conversion mode in this particular video. So let's get started. So here we are just going to do one more implementation, or we are just going to set another bit for enabling the continuous conversion. So that is available in the same CR2 control register 2 of the ADC peripheral. So moving to the ADC peripheral chapter in the user manual, and in the control register 2 of the ADC, you can clearly see. So this bit number 1, that is CONT, is useful for converting continuously the ADC values. So when you enable this particular bit, you can directly read the ADC value from the ADC data register directly after the ADC conversion is complete without triggering the ADC start. That is available right over here. So in the previous video we did that is we started the ADC conversion by setting the SW start, that is bit number 30 in this register, and we waited until the ADC conversion is complete and we read the value of the register, that is the data register of ADC. So for now we are not going to do this, we are not going to start the ADC conversion. Instead we will be enabling the continuous conversion mode in the ADC peripheral, so that the ADC peripheral itself will be keep on converting the ADC values from the configured channel, and it will be providing the result in the data register once the ADC conversion is complete. So for that we will be enabling the CONT bit, that is bit number 1 in this particular register. So let me just go to that particular bit in the register. When this particular bit is 0, single conversion mode is enabled, that is one shot conversion is enabled. When this particular bit is 1, continuous conversion mode is enabled. So I'm just going to set to the bit number 1, that is conversion mode enabled. So instead of again and again starting the ADC conversion right over here, I just want to start only once this ADC conversion before the while of 1. So here you can clearly see I am just enabling the continuous conversion mode and I am bringing out the start ADC conversion bit on the top of while of 1, meaning like I am not going to turn on the start again and again for starting the ADC conversion. Only once I will start, and rest of the times the ADC module itself will be triggering the conversion. It will not stop the conversion. So once on entering the while of 1, here we are waiting for the ADC conversion to complete and we are reading the ADC data register. And once on reading this flag will be cleared and again it will be held inside this while of 1. And as I said before, the ADC module itself will be triggering the conversion, and once it is complete again we are reading the data register. So the data register and the ADC data variable right over here will be updated with the new set of value that has been processed. So I'm just compiling this. So here you can clearly see we have moved the start ADC conversion line above the while of 1. So only once we are doing this, we are not doing this repeatedly inside the while of 1 as we did before, because this is continuous conversion mode. and inside the while of one we are having only two things. One, we are waiting for the converter to complete, and another one, we are reading the data register. Since the ADC continuous conversion mode is enabled, we need not trigger the ADC conversion to start. So the hardware itself will be continuously keep on converting, and it will be raising this flag automatically when the ADC conversion is complete. So we need not bother about that. So we are putting only these two lines inside this. I'm just compiling this program, and I'm dumping the flash by clicking on F8 in the keyboard. Now I'm moving to the debug view by clicking on the start or stop debug session icon right over here. I'm starting the program by clicking on this particular icon or F5 in the keyboard. You can see I am getting a random value. Now I am just going to provide 3.3 volt to the PA1. You can see I am having the maximum value, that is 4095 in my ADC data variable. Since this is 12-bit ADC module, I am getting the maximum value to be 4095, and I am providing ground right over here. You can see now I am getting the minimum value 011. Again I am just going to provide 3.3 volt. I am getting the maximum value right over here, and now again I am just connecting ground to it. I am getting minimum value 0123, etc. So by enabling this particular bit, you can just continuously trigger the ADC conversion in the ADC module of the microcontroller STM32F4 So in the previous video, you learned one shot conversion in ADC, and in this particular video, you learned how you can convert the ADC continuously by setting the ADC mode in continuous conversion mode. So by this method also, you can read continuously the data that is coming from an analog output type sensor by configuring the ADC module in continuous conversion mode in your microcontroller STM32F4 So I hope you learned something new in this video. See you in the next video. Thanks for watching.